All right, let's talk about a giant in the tech world, Amazon Web Services, or AWS. You've heard the name, and if you've ever felt like it's this incredibly complicated thing, well, you're not wrong, but you're also not alone. So today, we're going to pull back the curtain and make sense of it all. Let's get into it.
I mean, seriously, if you've ever opened up the AWS console and just felt completely lost, you know what I'm talking about. There are hundreds of different services for everything from computing to machine learning to, yes, literally satellite ground stations. It's totally overwhelming. So where do you even start?
Okay, so here's the secret. The best way to understand AWS is to stop thinking of it as a single product. Instead, picture it as a massive box of digital Legos. Each piece is a specific, specialized building block, and you can click them together to build almost anything you can imagine online.
So what is the cloud anyway? At its core, it's really just someone else's computers that you can rent. But with AWS, we're not talking about a couple of servers in a basement. We're talking about a massive global network of data centers, giving you instant access to unbelievable amounts of power whenever you need it.
Okay, so the first and honestly the most fundamental Lego brick you're going to reach for is compute. This is the engine. It's the brains of your whole operation. This is the part that actually runs your code and brings your applications to life.
The classic, the original compute service is EC2. That stands for Elastic Compute Cloud. The easiest way to think about this is like renting your very own server in the cloud. You pick the operating system. You decide how much memory and power it has. You have total control, just like it was a physical machine sitting on your desk.
And then there's the much newer, almost futuristic approach, AWS Lambda. With Lambda, you totally forget about servers. You just write a little piece of code, a function, and you tell AWS when to run it. We call this serverless, which is kind of funny because of course there are still servers somewhere. The point is, you don't have to see them, manage them, or even think about them.
And this right here is the core trade-off. With EC2, you get all the control in the world, but you're responsible for managing that server, and you pay for it 24/7 as long as it's on. With Lambda, you give up some of that fine-grained control, but in return you get simplicity and this huge cost advantage. You only pay for the exact milliseconds your code is actually running. That's a game changer.
Right, so this whole thing works on an event-driven model. It's super simple. You just upload your code, you connect it to a trigger, say every time a new photo gets uploaded or a user clicks a button, and that's it. AWS takes care of the rest. It runs the code when it needs to and scales it automatically. It's just incredibly efficient.
Okay, so we've got an engine to run our code. Now we need a place to, well, put all our stuff. And that brings us to our next big category of Legos, storage. These are the all-important pieces for holding your files, your images, your videos, you name it.
The undisputed king of AWS storage is S3, the simple storage service. The best way to picture S3 is like a bottomless digital warehouse. You create these things called buckets, and you can just toss anything you want inside them. It's built for insane scale and durability, which makes it perfect for everything from website images to massive data sets for data analysis.
Now this slide is super important because this is where folks can get a little confused. There are three main flavors of storage. You've got S3, which is for whole files or objects that you access over the web. Then there's EBS, or Elastic Block Store. Think of this one just like a virtual hard drive that you plug directly into one of your EC2 servers. And finally, you have EFS, the Elastic File System, which acts like a shared network drive that lots of different servers can all access at the same time.
And AWS isn't just for brand new applications built entirely in the cloud. A service like Storage Gateway actually builds a bridge between a company's own traditional data center and the AWS cloud. So as you can see here, it lets all their existing applications seamlessly use cloud storage like S3. It's a perfect example of a hybrid cloud solution that blends the old with the new.
Okay, so we have compute power and we have a warehouse for our files. But what about all that structured information? User accounts, product catalogs, order histories. For that, we need a library. We need a database to keep everything neatly organized so we can find it in a flash.
For that traditional structured data, stuff that fits neatly into tables with rows and columns, there's Amazon Aurora. This thing is a supercharged, cloud-powered database. It's compatible with popular open-source databases you might have heard of, like MySQL and PostgreSQL, but it's just way, way faster and more reliable. Think of it as a high-tech, self-managing library.
But what if your data isn't so neat and tidy? What if it's kind of messy? Well, that's where a NoSQL database like DocumentDB comes in.
It's built to store flexible data structures, like JSON documents. This is more like a modern filing cabinet, where each folder can hold a different kind of document. It's perfect for things like content management systems or user profiles that might change over time.
All right, we have our core Lego bricks. We've got compute, storage, and databases. So now the big question is, how do we actually assemble them into a final product and get it out to the world? For that, we need the assembly line.
The modern standard for building and shipping software these days is using something called a container. A container is just this neat little package that bundles up your application's code along with all the little bits and pieces it needs to run. The whole point is to make sure it works exactly the same every single time, no matter where you run it.
But what happens when you have hundreds or even thousands of these containers running at once? You need a system to manage all that chaos. That system is called Kubernetes, and EKS is simply the AWS managed version of it. You can think of it as the huge industrial strength assembly line you see here, automating how all those containers get deployed and managed across a whole fleet of servers.
But what if you don't want to deal with all that complexity? For a lot of people, there's a much simpler option: Elastic Beanstalk. This is like the ultimate easy button for deploying your app. It's the fully automated assembly line. You literally just upload your code and Beanstalk takes care of everything else for you.
And this slide is so cool because it shows you what's really happening under the hood. When you use Beanstalk, it's actually grabbing all those other AWS Legos we've been talking about and assembling them for you. You can see it sets up the EC2 servers to run your code, it adds a load balancer to spread out the traffic, it even handles auto-scaling for you. It builds a complete professional setup with just a few clicks.
And there you have it. We've gone from this huge, kind of scary cloud to what is hopefully a pretty clear and understandable set of building blocks. We've basically unboxed our digital Lego set and seen what all the most important pieces are for. So, to wrap it all up, the big takeaway here is to think in these categories. You have your compute, which is the engine. You have your storage, which is the warehouse. You have your databases, the library, and your deployment, which is the assembly line. If you can start with these core ideas, the rest of the massive AWS world becomes so much easier to figure out.
So we've seen that AWS isn't just one thing. It's a toolkit of pure possibility. Whether you want to build a simple website or a global streaming service that reaches millions, the basic building blocks are all the same. So the only real question left is, what are you going to build with them?